Hello friends, welcome back and welcome to our next video, that is types of graph part 2. So in this video we are starting with the type of graph that is called as histogram. Now the histogram chart visualizes the frequency of discrete and continuous data in a dataset using joined rectangular bars, and each rectangular bar defines the number of elements that fell into a predefined class interval. Now this histogram is, say we can see say it is similar to the bar graphs, but it is somewhat different in bar graph, that the bar graphs are we define the bins of bar graph, but here in histogram we cannot define the bin or the bin size of bin of the bar graph, as well as in histogram it shows the complete distribution of the data. So we will see the next of it. So first is a simple histogram. Now this figure shows the how histogram looks like, and this red line or this red spline is the distribution of that data, or it is the mean of that data distribution, right? So basically the histogram shows the distribution of data with respect to on the x and y axis, where on x axis it gives the values, sometimes it gives the standard deviation on the x axis, and on y axis is gives the its packing or say compactness of that data. And by using this simple histogram, or just by simply using the histogram, we can reasonably estimate any variables mean, standard deviation, skewness and kurtosis, right? So the mean is we know what is mean, as well as we know the standard deviation and skewness and kurtosis. So this is the form of a simple histogram. Now we will see the next, that is the normal distribution histogram, or the histogram which shows the normal distribution. A normally distributed histogram is a chart, usually a bell-shaped chart, means this outline of that chart will be having a shape of a bell. As the same suggests, this distribution is normal and is the standard for how a normal distribution chart should look like. Means look at this chart, it is a measured voltage on x-axis, that is 0, 1, 2, 3, 4 on the right hand side, and -1, -2, -3 on left hand side, and the y-axis shows the number of occurrences, how many times that voltage occurred, and the sample size is 100,000. So from that we can find out the zero error occurred most of the time, that is 8104 times the zero error occurred, and the 1 millivolts error occurred for 7633 times, while the -1 voltage error occurred at the 7811 times. So as the margin of error increases, its occurrence decreases on both of the sides, means on the right side and at the left side, and the shape or the decreasing in error is similar to on negative as well as positive side. So the overall shape of the histogram will be look like a bell. That's why it is called as a bell-shaped curve or a bell-shaped histogram. And when your data distribution or the histogram gives a shape of bell, then it is called as a normal distribution histogram, and your data is normally distributed, right? So this is the one case, that is the data is normally distributed. But what are the other cases when the data is not normally distributed, or the histogram is not a normal distribution histogram? Then there will be next type, that is a skewed distribution. Now what is skewed distribution? So skewed distribution histogram is an asymmetric graph with an off-center peak, usually tending towards the end of the graph. As well as a histogram chart can be said to be right or left skewed depending on the direction where the peak tend towards, right? Peak means where the highest value or where is the highest occurrence, right? So this first figure shows the right skewness or positive skewness, means when the peak of your distribution or histogram is at the left side of the graph, then it is called as right skewness or positive skewness. And on the other hand, when your peak of the graph tend towards the right side of the graph, then it is called as left skewness or negative skewness. So in the right skewness or negative skewness, your mean is not at center. It differs from your center position or from the center of your range of that your distribution. So normally when your data is not a normally distributed, then it will be a positively skewed, or when data is have positive skewness, it is called as positively skewed data, and when data is having negative skewness, it is called as negatively skewed data. Then there is a next third type, that is called as bimodal distribution. So what is bimodal distribution? In a bimodally distributed histogram chart, we have two groups of histogram charts that are of normal distribution, and it is a form as a result of combining two processes in a data set. So it is not necessary that we have to combine two results or two processes in one data set. A single result or a single data set or a single column in data set can also have the bimodal distribution. So how can we identify the bimodal distribution? We can have the two normally distributed histograms. Just we can see here, say from 0 to this approximate nearly 0.6, and from 0.6 to 1, there are two normally distributed histograms. So that is called as bimodal histograms. Also there are two different peaks in the histogram, so it is called as bimodal histogram. Now the next type of histogram is random distribution histogram or randomly distributed histogram. So this is type of histogram chart does not have any regular pattern, and it produces multiple peaks and can also be called as multimodal distribution. So just as for bimodal distribution there were two peaks, but in random distribution there can be number of peaks, and it doesn't have any specific pattern or any regular pattern, then it is called as random distribution, or due to it is having the multiple peaks, it is called as multimodal distribution also. And most of the cases the data comes under the random distribution histogram. In very few cases your data will be normally distributed, just like normal distributed histogram or the bell-shaped curve. In some cases your data will be positive skewed or negatively skewed, and many or say most of the cases your data will be in a randomly distributed histogram. Now these were the types of the histogram. Now we will move to the next type, that is the area chart. Now the area charts are used to collectively measure data trends over a period of time by coloring the area between the line segment and the x-axis. In simpler term, an area chart is an extension of a line chart. Means in line chart we were just plotting the line, but what we do in area chart, we color all the area under the line. Means the area between the line and x-axis is colored, and that is called as area chart. So we will see the next part, that is the types of area chart. The first type of area chart is simple area chart. Now in simple area chart there will be just one line or one area, or we can say as a one variable with respect to time. Now here the plot shows the yearly sales of iPhone from 2007 to 2016. So the x-axis will be the time span, that is 2007, 8, 9, 10, 11 up to 2016, and the y-axis shows the number of units sold, that is started from 0 to 4 million units. And if it was a line chart, then we will have the different points. I mean, there will be a point for 2008, there will be 2009, 10, 11, 12, and at the end there will be last point for the 2016, and we would have just joined that line, that all the points, by using a straight line. But in area chart we are using, or we are joining the points, but instead of straight line we are using a spline, or we are using a curved path to join all that points, and all the points are smoothly connected, and the area below those points is colored. That is called as simple area chart. Means the area shows your quantity, or say your value of y-axis. Means if the colored area is more, your value of y-axis is more. So this is the simple area chart. Next is the stacked area chart. Now, as the name suggests, in stacked area chart the color segments are stacked on the top of one another so that they do not intersect. So basically what they do in this stacked area chart, just it is the stacked area, means the color segment are stacked. Color segment are stacked means, first of all, the value or the variable which is having the higher y value will be plotted first, or will be colored first. Then here we will draw first the whiteboard's line, then next we will draw the line of projectors, and after that we will draw the line of printers, right? So that's why all plots will be visible. If we draw a line or the plot of the lesser one, then this plot will be hide behind this having the variable which is having the higher value. That's why we stack it on one another. But how? We first plot the higher value line, and then we plot the lower value line. So from after that we can see that directly that the values or the items sold in all the years for whiteboards are higher, or as compared to number of items sold for the projectors or the printers. So here we can directly compare whose sale is how much larger than the other parameters or other variables. And the next, this was the stacked area chart, and next type is the 100% stacked area chart. Now in this type of stacked area chart, where all the area occupied by each group of data on the chart is measured as a percentage of its amount from the total data, and this vertical axis is usually totals a 100%. Means in a 100% stacked area chart, on x-axis there will be a time span or time duration, and on y-axis the maximum value will be 1 or 100%. Just like we have here seen, their maximum value on y is 1.0, that is 1, or we can say it as 100%. This 0.8 will represent 80%, 0.6 will represent 60%, and on that, same as the stacked area chart, we put our values, but the values are not taken as it is. They are considered, or they are used as the percentage of its amount from the total area. So we can hear that there are three variables A, B and C. So the value of C are high as compared to value of B, and the value of B is high as compared to the value of A. So we can easily identify here that the value 1 or 1.0 to 3.0, the value of B is more, or the B variable is having more percentage in between 1 and 2.5, or say we can say 3, right? So these were the two main types, that is histogram and area chart, and the subtypes of the histogram chart and area chart. So thank you for watching the video, guys. In further videos we will see more types of graphs.